Hello friends, now that we know what a load combination is, we'll now define the load combination for our building. Okay, so for that, first go to design and click on concrete frame design and click on view revise preferences, and make sure that the code listed over here is the code that is followed in your country. So for example, IS 456 2000 is for now, and you can follow any other country over here. Okay, so after that, and click on OK, and after that go to define and click on load combinations. So after that, what you do, click on add default design combos and click on concrete frame design. Okay, and we click on OK. So after that, you can just see modify ISO combos, and you can see that all the dead load has been multiplied. Okay, so we had only 13 load combinations, but here it shows the 14. So load combination 1 is not that usable. Okay, so next, if we see, you can see that it's 1.5 dead load plus live load. Okay, so all these factors, and again, if you see the fifth combination, you can see it's for the earthquake in the y direction, and if you see the sixth combination, you can see the load combination in the negative y direction, right? So minus 1.2. Okay, so again, what we do, we just select this decon 1, and after that we press shift and click on the last option, and we delete all these combos. Okay, again we click on add default design combos and click on concrete frame design, and we check this option over here, convert to user combination editable. Okay, now you can edit these values as well. So for example, if you go to udcon 2 and click on modify ISO combo, here you can change the name, and you can also change the scale factor, right? So you can name it as 1.5, so it's DL plus IL, right? And we click on OK. So it's the linear add, right? And we click on OK. So after that, again we go over here and click on modify ISO combo. So it's 1.2, so DL plus IL plus, I think it's EQX plus EQX, right? So let me check. Yeah, it's EQX. So we click on OK, and again after that click on modify ISO, and it's minus EQX, right? It's minus EQX, so it's 1.2 DL plus IL, okay, IL plus EQ X, so it's not X plus, it's minus QX, right? And click on OK, and similarly you can change the rest of these codes as well, right? And we click on modify again. Okay, so let's just go over here, modify it, copy it, and after that go over here, modify, and let's paste, and it's plus EQY, right? Plus EQY, and we click on OK, and after that modify, it's minus EQY, and which load combination is this? So it's 1.5 DL plus 0.5 DL plus EQX, right? So copy it and OK, and modify, so it's minus EQX, right? And click on OK, flat, click on modify, paste it, plus EQY. Okay, and after that modify, paste it, minus EQY. Okay, and after that modify, so it's 0.9 DL plus 0.9 DL plus EQX, right? Truly is 1.5, sorry, 1.5 EQX. Copy it, click on OK, modify, paste it, so it's minus EQY, EQX. Okay, and modify it, it's plus EQY, and it's minus EQY. Okay, so why are we doing this? Changing all these options, because while studying the results of the analysis, it will be easier to recognize the kind of load combinations that we are dealing with. Okay, so we click on OK, and you can delete this option or you can just keep it as it is. Right. So next combo, we add one new combo. So add new combo. We'll name it as envelope. EVELOP envelope. Okay, caps is on. envelope envelope. And it's not a linear add, it's an envelope add. So what this is, I'll tell you in a while. Okay, so we'll just add all the load combinations that we defined just now. So we'll add them, okay, one by one, only the load combinations, keeping scale factor as 1. So 1.5 DL plus IL is gone. Okay, so after that, add plus EQX minus EQX plus EQY minus and just keep on adding plus EQY minus EQY. After that 0.9 okay, minus, after that plus, minus, and click on OK, and after that click on OK. Okay, so to explain what the envelope is, I'll first run this building. Okay, so let's go to any elevation and let's go to elevation A, and after that we'll just run this building. Okay, so we haven't designed our building yet, we are just learning. Okay, so after running our program, let us see the movement diagram of different frame members. Okay, so for that, what you can do, you can just click on this shortcut option over here, or you can go to display and click on force stress diagrams and click on this option over here, right? And here you have to select any design combination. Okay, so let's select 1.5 DL plus imposed load, and let us take the measure moment, that is moment M33, and fill diagrams, and we are doing off the frames. Okay, so click on OK. So here you can see that you got a certain value of movement over here. So if you right click on this beam over here, you can see the maximum movement at this position, right? So the maximum movement is, or what you can do is just click on show max, and the maximum movement is minus 8.6287 kilonewton at 0.170 meter, right? So now what we do, we click on done, and again we click on this shortcut option now, and after that we change the load combination, right? So let's select 1.2 DL plus imposed load, and we click on OK. Again we go to this beam over here and right click and click on show max. So here you can see that the maximum moment is 6.43 kilonewton, right? So the moment value has been changed. Okay, the moment value changes at each location, right? So, okay, so now I'll demonstrate you using my paint, right? For example, this is your axis, right? And due to a load combination 1, let us assume that the movement diagram is like this. Okay, so this is just an assumption. Okay, so due to the second load combination, let us assume that the movement diagram is this, right? And let us assume that due to the third load combination, the movement diagram is like this. Okay, so now what the envelope load combination does is that it takes the maximum value of each of these load combinations and makes a new curve. Okay, so for example, so it starts from here and joins this and join this. This is a new curve that is obtained by joining the maximum value of each of these moment curves. Okay, so this is the definition of the envelope load combination, and it takes the maximum value of all the moments or the shear force and generates a new curve, and the envelope values are used to design the beams manually. Alright guys, so this was for load combination. So this video was helpful, and in the next video we'll analyze our building and we'll see different aspects of it. Okay.